Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Mary Lou.
And in studio with us we have Graham. Graham, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everywhere else, call 1-866-636-6284. Our email address is dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. Do you have any of that social media stuff?
No.
I personally myself don't have any of that stuff either. But you know, with Do the Math, we have to have all of those things, right? So where do you go to school and what grade are you in?
I go to Stockton Elementary and I am in 5th grade.
How is 5th grade?
Good.
What's so good about it?
U.S. history.
U.S. history, excellent, 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 because that was one, I taught 5th grade for a while, and that was one of the best things about 5th grade was U.S. history.
Yeah.
So have you started it, or are you coming into it? Do you know what, like, have you started any U.S. history yet in class? Or?
We started a little bit.
Okay. So what do you like about U.S. history so far, or that you might already know from something else?
It's different from most other subjects, and it's something I'm interested in.
Good. Well, it's nice to know how the country got started and things like that, right?
Mm-hmm.
All right, good. So what kinds of math are you doing right now in your regular classroom?
Right now we're doing addition, subtracting, fractions.
Okay, so we might get to a little bit of that today, but you brought in some homework from a different class that you take part in, correct?
Yes.
And what is that class?
That is my GATE class.
Okay, and how is that different than your regular class?
It's usually more advanced, and you usually only do things that you wouldn't do in a normal class.
Okay, so it's like an enrichment. You get to do things that you wouldn't do in the regular classroom.
Yes.
All right, good. So let's take a look at one of your problems right now. So how about you and Mary Lou head over to the board real quick, and we're going to go ahead and solve one of these problems. So right now we have 12n is equal to 108. So go ahead and write that up on the board. 12n is equal to 108. And it looks as though it wants you to solve for n. So if you would explain to Mary Lou how you think you want to solve that problem.
I think you would normally do 108 divided by 12.
Oh, why? What makes you think that?
Because my GATE teacher taught me that a blank space usually means this multiplication, so that blank space would be about right there.
So when a number is next to a variable,
Yes.
you're saying that that's multiplication.
Most of the time, yes.
Okay, so the opposite of multiplication is?
Division.
So how would you solve this? Could you solve this mentally, or do you need to work that out?
I can do it mentally.
Okay, so what is 108 divided by 12?
That would be 9.
9, okay. So therefore, you're telling me that n
Equals 9.
Okay, write that down for me. Can we rewrite that to show that that is proof that this, to check that work?
Yes.
So how would we rewrite this, replacing the n with the 9? How can we rewrite that?
Multiplication.
Okay. And multiply that out so we can see that it equals it. Tell me what you're doing there.
I'm doing basic multiplication. When you're doing 1 digit times 2 digit, take the smaller number, you take the final digit and carry the rest up here.
Okay, so you're saying 2 times 9 is?
18.
Is 18, okay.
And then 9 times 1 is 9, plus that 1 equals 10.
So it checks out to be?
108.
108. So therefore our missing variable is?
9.
Is 9. There you go.
Nicely done. Easy first problem right there, and I'm glad you were able to do that one in your head because you understand that that variable does mean multiplication when you have that next to the number. All right, come on over here real quick.
Good job.
Just a reminder, we do have phone tutors available until 5:30. It is mid-November. You know what that means?
It's getting close to Thanksgiving.
Getting close to Thanksgiving, correct? We will not be here the week of Thanksgiving, but when we come back after that week, we'll be giving away tickets to Holiday Lights at Cannes. So that's going to be a little something right there to look forward to. But before we get to any of that other stuff, let's first take a look at today's Math in the News. All right, so look at me. Whoa, that's why I wanted you to look at me, because I knew you were going to look back there real quick, and it wasn't up on the monitor, all right? So I didn't mean to turn you quick there, but, and you're looking at me
Okay.
also, all right? So I don't want you guys looking at the monitor.
Okay.
All right? Have you ever been places where it's very crowded?
Yes.
Where?
Actually, in London. It was
In-
very crowded.
So the city of London,
Yes.
just being out and about, was very crowded?
Yes.
Okay, have you ever been someplace that's been very crowded?
I've been to airports before.
So in airports, it's been very crowded, especially around the gate that you're
Yes.
probably getting ready to go on a plane, right? So it's been very crowded there, okay? So there are a lot of places where crowds naturally form,
Yeah.
okay? Do you think the Earth is pretty crowded right now?
Yes, I would say.
Okay.
In some places.
Some places, true, right? Because
I
there are
agree
some
with
places
that.
where you don't even have any people living for hundreds or thousands of miles,
Yes.
right? How many people do you think are on Earth right now?
Say around like 7.5 to 8 million. Billion, sorry.
7.5 to 8 billion.
Yes.
All right. You think that's a good estimate?
I think that's a good
All
estimate.
right. Well, you know what? I turned them so you can see my monitor here, but not the big monitor. Anyway, I'm sure you weren't looking at that, but let's go ahead and have you looking back at the cameras again. So on Earth, today is when stats people all said that today, for some reason, today is the day that Earth hits 8 billion people.
Wow.
That's why we're doing it today on Math in the News, right? So 8 billion people are on Earth today. Now, let's take a look, right? Here's some crowds. Have you ever been in a crowd like that outside? So London probably was like that,
Yes.
right? Have you ever been like this one on the far right? Have you ever been in that many people around you at that time?
No, I don't believe so.
Probably not. The middle one and the one on the far left looks like a major city. Kind of reminds me of being in Manhattan,
Oh, yes.
right? Major
Yeah.
cities like that where you've got people just all over the place. And there are some people that are fine with that. And
Some
they
of
can
us are
maneuver and things like that and get around. And then there are a lot of people that do not like that.
Yeah.
Yeah, I think Mac is comfortable with a lot of people like that walking through a city, but Mick isn't. He doesn't want that crowd and stuff like that. Would you think you would be comfortable in a group like that, those photos up there, having that many people around you?
I believe so, yes.
Okay. What about all the time? Like every day, that's what you had to deal with?
Probably not.
Probably not. Okay, so there are people that have to deal with that every day. But anyway, it says today the population of Earth will reach the 8 billion milestone according to the United Nations projections. So it's the result of an epic growth spurt in the last century. So 1925, 100 years ago, there were 2 billion people. 50 years later, 1974, let's just make it 1975,
Okay.
it doubles to 4 billion. So in 50 years, the population doubles. So since 1975, another 50 years, it has doubled before the 50-year mark.
Oh.
Because that would be 2025, 2026, right? So it's doubling faster than it used to.
Wow.
So why do you think that rate is increasing now? I mean, any idea is not wild. Any idea why? Because 100 years ago, it went from 2 to 4. And that doubled, which is a lot, but it's only 2 billion people. Now we've gone in the last 50 years from 4 billion to 8 billion. That's 4 more billion people. Why do you think there are more people now as opposed to 100 years ago? And I know this is kind of a tricky question, they throw you on the spot right here, but any ideas why there might be more people now?
No, not really.
Okay, Mary Lou, what do you think? Why would there be more people now?
I'm just thinking of, those percentages and the doubling, right? So you had your 2 billion in 1925, right? And then you had 4 billion. Well, now you have that 8, and I'm thinking of it mathematically on how that's doubling.
So do you
I'm seeing almost like a pattern.
Okay, do you think 50 years from now, it'll go to 16 billion?
That it could be. That's
Because some
what
people
I'm
might go,
thinking.
well,
Yeah.
but they say by 2080, another 50 plus years from now, right? And when we're talking to you on Do the Math in the News that day in 2080, there will not be 16 billion people on Earth, because they say it's going to probably top out at about 10 to 11 billion people by 2080.
Oh wow.
Because fertility rates, people not having as many kids as they used to 100 years ago. But the reason there's been the growth from 4 to 8 billion right now, recently in the last 50 years, is because of the advancements in medicine.
Oh yes.
People taking care of themselves more, right? My grandparents didn't live into their 70s, right? But a lot of our parents do live into their 70s and beyond. And those of us that are a little longer in the tooth right now, right, will see that very soon.
Yes,
right?
yes,
I mean,
yes.
within a decade, bam, we're there. But kids like Graham, they can expect to live close to 100 years old. So if you have a lot of people living longer because of advancements, you're going to have more people on Earth at a certain point. Does that make sense?
It's
Yes.
more knowledge based on, what's keeping us young and healthy.
Right. And there are many advancements as to, hey, take these vaccinations, even, these medicines, and they will prolong your life.
Yeah.
That is a major reason why you see a big growth in the last 50 years as according to the last 100 years.
Yeah.
It doubles, but doubling billions of people is a lot of people when
Yes,
you start
it is.
doubling that thing. But anyway, that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors usually on Tuesdays and Wednesdays until 5:30 in the afternoon. We have Graham, a 5th grade student from Stockdale Elementary, and you are working on some different math because of your other classroom, correct?
Yes.
All right, so why don't you head over to the board, erase that, and let's get busy with the next one. And this
Okay,
one,
just hit that red X for me right there.
something a little different because you've got some
There you go.
negative symbols in here now. So negative 45
Go ahead and write that.
Okay.
is equal to negative 5n. All right, take it away.
So, looking at this, are you comfortable with the way it's written?
No, not fully.
Okay, would you like to rewrite that so it kind of makes a little bit more sense to you? How would you rewrite that so it makes a little bit more sense? So explain to me how you rewrote this.
I rewrote it because by taking the 5 and as student, the first problem I figured I can use multiplication with a blank number to find that answer.
Okay, so is this a multiplication sign or is that your variable?
That is a multiplication sign.
Okay, can I put a line right here?
Yes.
Because that's what you want to find is that variable, right? So you kind of flip the problem.
Yes.
You like reading it from left to right.
Yes.
Correct? Okay. And is that okay? Is that okay with it? We're not breaking any rules, are we?
No.
No, we're not. You're actually making sense of the problem and you rewrote it the way you like to see it, which is perfectly fine.
Okay.
So now you wrote it as -5 times some unknown number equals -45. Is that kind of a lot easier for you to think mentally of what that number could be?
Yes.
So before we go to that number, kind of explain to me your knowledge of these negatives. What do you know about negatives?
I know that if you multiply a number with the same positive or negative sign, it will be positive.
So you're saying if I have I'm going to do a little positive here. If I have a positive multiplied by a positive, then that's going to give me a
Positive.
So if I have a negative multiplied by a negative, that's going to give me a
Positive.
positive. Okay. Then what happens if I have opposites of each? Either a negative multiplied by a positive, or I could say a positive multiplied by a negative. What answer am I going to get then?
It's a negative.
Oh, it's a negative. Can you tell me a pattern that you're seeing here with these? What do we see here? Here, how many negatives do we have?
We have 2.
And we have 1.
Positive.
And what pattern do you see here? How many negatives do we have in this problem?
2.
And how many positives?
1.
How many negatives do you see here?
2.
And how many positives?
1.
Do you see a pattern there?
Yes.
So if we have 2 negatives, right?
Yes.
Negative, negative, or having them on the left side of that equal sign, our answer has to be.
Positive.
But if we have a negative and a positive, I
Yes.
need a,
Negative.
because I need that second negative, don't I?
Yes.
In there. But again, we have those negatives, right?
Yes.
So understanding that, let's go back to our number here.
Yes.
So what do you think our missing number could be?
9.
9, okay. So let's write your 9. Now here's the question. Do you think it's going to be a positive 9 or a negative 9?
It's going to be a positive 9.
Why?
Because there's already 2 negative signs.
So we have to have our
Positive.
there. And yeah, you're absolutely right. So again, if we have our -5 multiplied by 9, because remember multiplication is groups of, right?
Yes.
So we have -5 groups of 9, which is going to give us
Negative 45.
-45. There you go. Nicely done.
Nicely done. So, Graham, I know that when Mary Lou said, "Do you like the way this one is written?" in that way, you said, "No, not really," and then you rewrote it again.
Yes.
That's exactly what you want to do.
Yes.
Make it so that it's more comfortable for you and a little more recognizable for you to solve the problem. How you feeling? Pretty good?
Yes.
Good. Get back to the board. You're
All
not
right.
done yet.
Hit that X again for us.
All right, here we go. Now, let's see how you feel about the way this one's written.
Ready?
N over 7.
Oh, you're good.
You're fine. Yeah, just don't have your arm next to the board as close, that's all. So N over 7 is equal to -6.
All right, Graham, what does that mean?
I'm pretty sure it means division.
Okay, and are you cool with the way that this looks?
No.
Okay. Do you want to change it up so you're more comfortable with it?
Yeah.
Okay, go ahead. How would you rewrite that? So, tell me how you rewrote it.
I wrote N divided by 7 equals 6.
What kind of 6?
Negative 6.
A -6. So, pretty interesting. So we have a number divided by 7 equals -6. How are we going to figure this out? Let's save the negatives, talk about that at the end, okay? Let's just focus on our numbers. How are you going to figure this out?
I think I might be able to do multiplication.
Okay, show me. How would that look with multiplication? Oh, so you're saying 7 multiplied by 6.
Yes.
So we have 7 groups of 6, which is going to equal,
42.
okay. So let's put that 42 right back here and see if that makes sense, okay? Does 42 divided by 7 equal 6 make sense?
No. Wait, yes, sorry.
It does, right?
Yes.
Because yes, you are right. 7 multiplied by 6 is 42. So we know 7 groups of 6 is 42. Now let's talk about our negative. We have a negative on the outside here. We know our 7 is positive. So that 42
Must be a negative.
must be a negative. Okay, so let's make sure we put that negative there. And so Graham, when we write our answer, for mathematicians, we like to note our variable. So can you give me over here n equals? What does n equal?
Negative 42.
Negative 42. There you go. So after you did that, at first you were kind of uncomfortable with it, and then you kind of made sense of it yourself. What do you
Yes.
think? Is it as difficult as you thought?
No, it's not.
No, especially when you make sense of it yourself, it becomes quite easy, right? And you see the pattern. Good job again.
Well done. Well, for those first couple of problems that you've done well on, you've got yourself a meal courtesy of our friends at Chick-fil-A. So congratulations. Have you ever been to Chick-fil-A, Graham?
Yes.
You do? You like Chick-fil-A?
Yes.
What is your favorite thing on the item on the menu over there?
Probably the waffle fries.
The waffle fries. You like the waffle fries? Waffle fries are pretty good. You know what? Waffle fries, old man eat those, but not all the time. I like that spicy burger. That spicy.
No, thank
easy
you.
with the buzz. I don't know what's going on with the buzz there. You know, I eat the
Disagree.
nuggets too, you know, and stuff
Disagree.
like that. But yeah, so when you go over to Chick-fil-A and you have your free meal, when you go in, if you remember, ask for Troy.
Okay.
Okay, Troy is the one that owns the Chick-fil-A, and he loves do the math, which is why he gives you guys these free meals all the time.
Yes.
So if he's there, you can tell him you were on the show and say thank you to him, all right? Yes. All right, nicely done. Hey, we will have Graham on until 5:30 this afternoon. We'll have somebody from the Bakersfield Symphony Orchestra in right after this.
Hello everybody, my name is Ross Salcido. I'm with the Southwest Carpenters Training Fund apprenticeship program out here in Bakersfield, California. What I like to do is I like to introduce you guys to reading a tape measure. So what I have is here a dissect of 1 inch. In 1 foot we have 12 inches. Each inch consists of 16/16ths of an inch. So out there in the field when you're measuring, you want to measure 1/2 inch, you go 8/16ths, with 8 times 2 is 16, 16/16. So as we go through the tape measure readout, we go with the first tick, which is 1/16, second tick, 1/8, 3/16, 1/4, 5/16, 3/8, which is 6/16, half, which is 8/16. Then we have the 9/16, 5/8, which is the 10/16, 11, 3/4, which is 12/16. Then we have 13/16, 7/8, which is 14/16, and finally we get 15/16, and to end up with 16/16. So how do we apply this on the field? So when we hook up a tape measure, we have the connector at the end, which basically what it has a little play on it, but this tape measure, what it does, it has a pull and a butt to it. So when you butt the tape measure to it, it creates that slag, the difference, which is that 16th of an inch at the point. When you tug on it, it's going to expand that 16th, so that's going to cover the actual dimension from the point of projection to the end, okay? Understanding that you have 12 inches in a foot, and you can dissect it to the 16th, and that's what we have here on a tape measure.
There we go, another one of the tools of mathematics, something that a lot of people use all the time, but sometimes get a little messed up once in a while
Yes.
with a tape measure and exactly how to read that and use that as well. We do have phone tutors available until 5:30. It's always fun to have people in studio with us. We are once again very grateful to the Bakersfield Symphony Orchestra for coming in again this week. And with us right now we have trumpeter and Mike. How are you this afternoon?
I'm very good, thank you.
How long have you been with the symphony?
You know, I have played with the symphony for almost 40 years, with the last 15 being the principal trumpet. Although I did retire recently, taking a little bit of an easier role, although I still do help them out on occasion.
Well, there you go. Well, congratulations on your retirement. Congratulations also on being with the symphony for that long. And what will you be doing with Graham this afternoon?
Well, I want to tie a little bit of my love of music and my love of playing the trumpet. And, you know, there's an interesting connection between math and music. I understand that, Graham, you play a musical instrument. What is it?
I play a snare drum.
Yeah, now percussion like that is a wonderful instrument to learn some of the rhythm, and rhythm is such a big part of music. And that math connection again. Did you know, going way back even to Pythagoras, the man who practically gave us the triangle, might have even given us the orchestral triangle that you hear. Believe it or not, as the story goes, he was walking along one day and he heard blacksmiths working. Maybe they were working on a bronze bust or something, and they were hammering, and he liked the sound of the hammers, and he noted there were different pitches in some of those. And he actually set about trying to weigh, he developed a scale to weigh the different hammers. So if you heard a hammer, if you heard a really heavy hammer, do you think it would be lower pitch or higher pitch?
Probably lower.
Right, and that's what he found. And he actually developed this scale. They think that's even where the musical scale might have come from in the early days, that idea. So that goes back to that connection of music and math. Now, if I may talk a little bit about the trumpet. So you maybe have not dealt with a trumpet, but you know, it has all these little tubes that go all the way around, and the valves that even route. If I push this down, it routes the vibrations around different tubing. So if you think, like, what if there's a longer tube that it's going through? Again, would that vibration make a lower sound or a higher sound with a longer tube?
Probably a lower sound.
You got it. Again, you're right on it. So, but the thing is there's only 3 valves, but I have to play a whole lot of notes. So this is where we're going to come into the whole thing, and we'll make you a little quick mini trumpet player. So if we're going to make a sound with the trumpet, we have to, what? We don't just blow, we have to, do you know?
Exhale?
No, buzz your lips. So as strange as it sounds, go ahead and do this with me. So we're going to go ahead, put your lips together like you're saying the letter M, okay? M, and then kind of blow out through that, and it's going to come out. Can you try that? Try really tight now. You kind of get the idea. You got to go. You got to really keep it tight. Sometimes what might make it easier, here is a clean mouthpiece. Go ahead and grab that out right there. And so in the trumpet, we have to compress that buzz into the mouthpiece. So in a sense, if I was doing that, I would be going. That doesn't sound like a whole lot. Try that just for a second. It's that getting that buzz. So it's really hard. Believe me, we spend our lives trying to do this buzz and trying to develop the things. So as ugly as that sounds, doesn't sound like much, But again, if you come into the trumpet, it goes through and it comes out. I have a little mute in, I want to note, so it doesn't overwhelm the sound here of the camera. You go, and it comes. So you hear, that's how the trumpet might sound. And it all comes from those vibrations, all the vibrations that are coming in there. And you know, you can even take and figure out the vibrations from a low note being really wide, that whole idea to a higher note as it goes really narrow. But let's go ahead and break out. So we sort of got some basics on the trumpet. If we can now, let's go to the things that you have been doing in reading music. Now, music is really like a language based with a lot of math principles. So you might have seen, if we come up here, just a simple thing, there is always the idea in a 4/4 bar, let me step here, 4/4, there's going to be 4 beats in each measure. So in other words, a whole note, the whole set of measure that defines this musical piece is going to start with a whole note, which has 4 beats, 1, 2, 3, 4. And again, that measure would still be then broken up. If you did 2 beats, you could do a half note. So again, this breaking out, each of these gets 2 beats, as you know. Okay, and then if we come into quarter notes, just like that sound, it's divided into a quarter. So each of these gets their own beat. And on down the line, what would these be?
Those would be 8th notes.
8th notes, exactly. So again, there are 8 of them here, and each of those equal
2.
Each of them equal even 4 when you get all 8 of those in there. So, and then you can even keep going down from 16 to 32. Yeah. So, you kind of get the idea. This is all that breakout of what math and music all is broken into this. It's amazing because even with little babies, they found they sometimes would play Mozart because they found that babies sort of developed better. They found, you know, ideas in their brain would sort of trigger things just by hearing the structure of that music. And they even find that young kids like you do better in later years if you take up a musical instrument, if you play something. So what you're doing now, even with your percussion, is a really good thing, that you can really learn more about math, and you don't even realize you're doing it. So let's go on and try to break out a little bit. We were talking earlier a little bit about conducting and how that would work, and let's see if we can make a little bit of a conductor out of you to break out some of these ideas about that. So if you're a conductor in front of an orchestra and you want to line out what these 4 notes are, okay, you're going to go ahead and kind of put your arms out, and let's stand right alongside. And with that, we want to count the first beat by just going up here and down 1, okay, and then 2 you'd come in, and then 3 you'd go out, and then 4 you'd go back up. So this is always going to be 4 going up, this is always going to be 1 going down. So let's start that up going 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Got it. That's it. And that's kind of how it breaks out. Now, if a musician is watching you, he knows how to follow you. And if you speed up or slow down, we have to follow you. And if we get a whole bunch of more notes, like 8th notes, 16th notes, we still have to follow that basic rhythm. Again, all the math, all the structure within each of those measures is going to be the same. So let's just see if we can do this. Let's see if you can go ahead and play. We'll just do this here. Now, I want you to put your arms up, okay? And you're gonna go 1, 2, 3, 4. Keep going, 1, 2. Keep going, don't stop. So you get the idea. Within that music, you can hear almost each of the beats. And even if I speed up the rhythms, I still have to follow, in a sense, what you're doing on that time. So it's just one of those wonderful things with music, how it all lines up. And so fairly simple compared to some of the math that you were doing right there. But believe me, you can spend a lifetime kind of learning this whole language that it is. So I'm glad that you're taking up an instrument. So perhaps you can come out to a symphony concert sometime. So we do have, in fact, a symphony concert coming up on December 2nd, where it's more of a holiday concert. So, and you know, you might know some of the songs, like, I'm sure you've heard of this one before. There you go. That last thing was kind of a little sound effect. Trumpets make a good horse. So, but otherwise, I do hope that you can come out and join us sometime there. There's so many wonderful things in music going on right now. I'm currently playing even at Stars Dinner Theater with a Billy Elliot show, which is just great, about a kid learning how to dance. We got a holiday show coming up. The symphony has its holiday show. Even coming up in February, I believe February 4th, the symphony is going to be doing the instruments of Harry Potter with all that great John Williams music. So that's actually a really cool thing. So if you can catch that, that's February 4th at the Mechanics Bank Theater. So a lot of great things coming, and you know, I hope you can come out and enjoy that.
All right, Mike, it sounds like there are a lot of great things coming, especially with that Christmas, the holiday show coming up. Where again can people go to find out more about the symphony?
The symphony can be found online at bsonow.org. So easy to find, Bakersfield Symphony Orchestra, BSO Now, NOW. .org.
All right, so Mike, before we let you go, I'm going to just throw the camera guys off here for a second. So Mary Lou, you and I are going to try this, where Mike had Graham purse his lips together and try to make that sound. So you and I are going to try this, okay? And see if either of us can even do this, all right?
Okay.
So here.
Okay, hold on.
Are we there, Mike? I mean...
Well, you're getting it, but you might make a good trumpet player someday. Just keep practicing.
Maybe we take out the percussion, right? We don't have to ask. But anyway, once again, thank you, Mike. Thanks for the Bakersfield Symphony Orchestra coming in. We truly appreciate you guys coming in. It's always a very special treat to have you guys in the studio. Thank you once again. We'll be back with more right after this.
Thank you.
I think it's given me an opportunity and an outlet to work on things more. That's something I've always enjoyed, but being able to come here every day in the beginning of the year at least and just work on things and learn things. I've always loved learning things about mechanical stuff. I've always been taking stuff apart when I was little, putting it back together. and this has just given me a way to be able to do that every day.
My certifications in this field, so my background is that 10 years ago I actually took this class as a student, and then I got into a training program for Caterpillar. I worked for Quinn, that's the cat dealership, worked for them for 6 years. Most of that was out in the field as a field mechanic. So I had earned an associate's degree through their training program, and then I spent 4 years out in the field, worked on all different types of Caterpillar equipment, including a lot of AGCO farm tractors and that whole line as well. So a really big variety there, and a lot of time spent on all different types of equipment before I started working here.
Internships, it can be a lot of different things. One day they could have you washing tractors, or the next day you could be rebuilding a whole engine. It all depends on what your boss has confidence in you doing.
Internships, we talked about them right at the start of the year, and the students that I'm able to send out into that are students that have performed well in class, they've worked hard, they want to be here, they have good attendance. Is a big factor of that because they're going to be out at a job site.
It kind of changes throughout the year. At the beginning, we'll start working on little lawnmower engines that you'd see on just normal lawnmowers. You're running around, tear those down, rebuild those. We move on to little two-stroke chainsaws, kind of just learning basic engine theory. And then after that, we bump it up to the big 6.0, 6.8 John Deeres that we're tearing down.
And thanks once again to all the staff and students at ROC and CTech. They self-produce all of those videos that we've been watching last year and this year, so a big thanks to those guys. We do have phone tutors available until 5:30. Graham is a 5th grade student from Stockdale Elementary in studio with us. And nice to get a little music lesson there, right?
Yeah.
All right, you ready to do some more math?
Yes.
Back to work, young man. Here we go.
All right, kiddo.
So now
Here
we
go.
have -6 over n is equal to 3.
Okay, so walk me through this. What are you thinking?
Think I'm going to do -6 divided by 3 equals blank.
Okay, explain to me why you decided to put the 3 as the divisor.
Because I feel like that comes at the end. That might help with the flipping the problem.
Oh, okay.
As if this was here, you just flip those around.
Kind of like fact families, right?
Yes.
Okay. So what do you think -6 divided by 3 is equivalent to?
Well, since -6 divided by 3 is 2, and
Okay.
since from the second problem, we need another number, another negative sign.
Okay.
6 divided by 3 equals 2, and then you put the negative sign there.
Okay, show me. So can we rewrite this way to see if that makes sense? So let's do our
Yes.
numerator is at -6. and do your fraction bar. And let's put our -2 as our denominator. So does -6 divided by -2, does that equal +3? Does that make sense?
Yeah, it does.
Okay, put equals 3 for me. And again, remember we talked last time, how do we accurately show our answer?
We do multiplication.
Well, what's our variable?
N.
So what does n equal?
N equals -2.
Write that correctly for me.
2 times.
Oh, just put your n. Remember, n equals. Because that's what we're trying to solve, right? We're trying to solve what that missing number is. There you go. I really appreciate the way that you are rewriting these to make sense to you.
Okay.
To make, to solve this quickly. Great job.
All right, clear the board.
All right.
You're on a roll. I think as though you feel pretty good about those, right? You pretty comfortable doing those now?
Yes.
Excellent. Time to move on.
Okay.
Mary Lou, write this problem up at the top of the board. 2x minus 3, open parentheses, x plus 6, close parentheses, equals -4, open parentheses, x minus 1. Close parentheses. Graham, how comfortable are you with this?
It looks confusing, but I feel like if I have some pointers, I could figure it out.
I
Proper
love it.
attitude. All right,
I love
let's go.
that. Okay, so what do you know? Tell me what you're comfortable with on this.
I feel like I can figure that out.
Okay. Well, we know that this is two groups of some unknown number, right?
Yes.
But we don't know what that is yet.
Yeah.
Okay. We know the parentheses has an unknown number
Yes.
plus 6, right?
Yes.
Again, we have the same variable throughout. So our job is to solve that variable.
Yes.
Like you've been doing, you've been figuring out that unknown variable. That's our job. We have to figure out what this unknown number is, okay? So we're going to start with think of order of operations. This is kind of out of order and we have to put it in order to solve it, okay?
Yes.
So we're going to start here. And this 3, is that 3 a positive or a negative?
It's a negative
It is a negative. Why is it a negative?
because of that right there.
Right. Have you heard of the distributive property before?
Yes.
Okay, when we have the distributive property, right, we're kind of breaking things apart. We're distributing it to make sense of it, right? So we're going to start with the distributive property. So what we're really saying here, we're going to take our 3 because this is really saying, I'm going to cover the 2x right now. This is really saying that I have -3 groups of x plus 6.
Okay.
Okay? So I have 3 groups of this, 3 negative groups of this. So let's start with -3 multiplying that by x, okay? Which we don't know what the x is, right?
Yes.
So this is going to be just -3x,
Yes.
okay? Then we have 6, right?
Yes.
So I have -3 groups of 6. What are -3 groups of 6 equal? Well, what's 3 groups of 6?
3 groups of 6 is 2.
3 groups of 6.
Wait.
So 3 multiplied by 6 is?
18.
18. And is it going to be a positive or a -18?
It would be a negative.
And because it's a negative, I'm going to show it as our difference, okay?
Yes.
All right. Let's pull down, I'm going to have you do this. Pull the 2x straight down. Just rewrite it for me, okay? So, Graham, what we're really doing is we're simplifying this to make sense of it, all right? So we're kind of simplifying this side. We're going to wait and do this in a second. Because these have the same unknown variable, this is saying I have 2 groups of x, and I have another -3 groups of x, okay? So if I have these x's, these are positive,
Yes.
but those are negative, okay?
Yes.
What do I have more of? If I have, I'm going to represent this with that. So I have 2 groups, right?
Yes.
And then I'm going to show these as negatives, okay?
Yeah.
For every positive and every negative, it zeroes out. That's called the zero property. So this is 0. This is 0. What am I left with?
Negative.
A negative. I'm left with one negative, huh?
Yes.
I'm left with one negative x.
X. Yes.
So I have a negative x left, all right?
Okay.
And then I have my,
Negative 18.
okay? So we have simplified this down. And you're using all that wonderful knowledge of positives and negatives with adding, subtracting, and multiplying, okay? Thinking about what we did here with distributive property, do you think you can solve this side for me?
I think I can try.
Okay, go for it. What did we do first with this?
That. Let's see.
Again, this is on the outside, and when it's on the outside, am I adding or am I multiplying this?
Or multiply.
Okay, so what do you think if I multiply these together?
You would get negative 4 groups of.
X, very good, write that for me. Perfect. So now we multiplied this, right?
Yes.
Now we're going to need to multiply this. And I have a negative multiplied by a negative, which is going to give me a
Positive.
positive what?
Positive X.
Not a positive x, but a positive.
No.
What's 4 multiplied by 1?
4.
So it's going to give me a positive.
4.
Can you give me a plus 4? So again, we're using that distributive property to help us, okay? So we're simplifying this down, we're breaking it down. So now what we have to do is that we have to balance this. We have x's over here, we have x's over here. We have a number, this is called a constant on both sides, right?
Yes.
So we're going to first simplify our variables. And a lot of times, I'm going to move this up for us, a lot of times it's called the inverse operation. What I do to one side, I have to do to the other. So I need to get rid of this x. And as we saw here, if it's a negative, in order to get rid of it, I have to do a
Positive.
positive. Can you put a plus x underneath there for me? That zeroes it out, right?
Yes.
So that just zeroed this out, so we're going to put a 0 there. But what you did here, can you also put a plus x underneath that? So here we have one positive x, but I have a negative 4x. So this is almost saying like subtraction, right?
Yes.
We're taking 1 away because again, I have my 4 negatives and I have a 1 positive. If I take this away, what am I left with?
3 more negatives.
3 negatives. So we're left with negative 3 x's, right?
Yes.
We still don't know what that is. And we have our plus 4.
4.
And we still have, what do we have on this side? We still have a
Negative 18.
we still have a negative 18. So now that we got rid of our variables, we're balancing them out, we've moved all of our variables to one side to kind of simplify it. Let's get rid of this 4. How are we going to get rid of the 4 on this side?
Negative 4.
Thank you. If you do negative 4 on that side, what are you going to have to do on this side?
Negative 4.
Yeah. Okay, so these are all negatives. So think of a number line, okay? If I have a number line, and this is 0, and this is negative 18, right? Because we know that the negatives go that way.
Yes.
If I have negative 18 and I'm taking away another 4, when we take away, right, we're still moving more to the
Left.
To the left. So if I'm continuing to move this way to the left 4 times, what do you think that's going to be?
24. Negative 24.
Yeah. Well, is it 24 or 52.
22. Yes.
22.
Negative 22.
Yes, can you put a negative 22 underneath there for me? We zeroed that out, right? And we have negative 3x left. Now, Graham, are we down to something that you have been solving? Ooh, did we make a mistake somewhere?
No, this is going to be
Okay, so this, we're not
a
going to have a
lesson
whole
for him
number.
here.
Okay, we're not going to have a whole number, are we? So now, that's not going to be a whole number, right?
Yes.
Because we know if this was 21, it would make sense, right?
Yes.
Because then we know that that would be 7, right?
Yes.
But we know that this is multiply, and the opposite of multiplication is?
Division.
Division. So we're going to divide both sides by negative 3,
3.
right? We could either simplify this or we can leave it as is. But a negative and a negative gives us again a?
Positive.
So we can actually write it as 22 over 3 equals x. And I'm not sure if we made a mistake somewhere.
No, I was looking at
Okay.
it, but as soon as I saw you come up with 22, I was like, all right, we either need 21 or 24 to make this thing
Yeah.
nice. But it could just be the problem that they emailed in
Yes.
also.
Yeah.
So I will give you 30 seconds to simplify that into a mixed number.
Can you simplify this to a mixed number?
Yes.
Okay, go for it, real quick. How many times does 3 go into 22?
Yeah. Okay.
Just think about 3 times what is a number close to 22?
7.
Good, give me 7 here. Put a whole number 7. And what is left over?
1.
1, numerator. And our denominator stays.
3.
Got it. Boom. So 22 over 3 is the same as 7 and
1/3.
Good job. Look at all that. So what you're doing with your homework, this is where you're going to be going next with it.
Okay.
And you got this. Nice job.
Nicely done. Come on over here, Graham. So, based off of what we did with your homework, do you feel better about your homework now?
Yes.
Okay, so you have a better understanding. You think you can do the last 1 or 2 problems on your own?
Yes.
Okay. If for some reason you needed help, do you have any idea who could help you with your homework?
Yeah, I could call in and
Yeah,
get
you
in.
could call in to do the math, right? Because
Yes.
you can call in on Tuesdays and Wednesdays,
Yes.
right? We'll help you do your math, right? And you better understand it. So, did you learn a little something today?
Yes.
Good. Did you have fun today?
Yes.
Did you like the part with the Bakersfield Symphony Orchestra over there?
Yes.
That was pretty cool
That
being
was-
able
that was
to
my
do
favorite
that.
part.
So, how long have you been playing percussion?
About 2 months now.
Okay, because in 5th grade, that's a brand new thing for you guys, right? Being able to
Yes.
start band and orchestra and stuff like that. So, who knows? Maybe you'll take up percussion and maybe one day you come up with a little brass, a little wind instrument and do some trumpeting also maybe later. Sound good?
Yes.
All right, who knows, right? Hey, we do have phone tutors until 5:30, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.